Okay, here we are back to this. You should have found page 195 in your math workbook where it says work with remainders. Before we actually do this, I want to put that aside and I want to, at the bottom of our journal, make a big red open box. And this is right with, where we ended right here. We're going to do a big red box underneath it. So with the remaining space, I'm just going to do a big red box. It kind of goes from one margin line to the other. And what we're going to do in this box is write some words that we would maybe see in a story problem that would indicate that this is a division problem. So this is how to look at real world problems and search for words that would tell me that it's division. Okay, so I will just begin by listing some of them, and I'm sure you can come up with some of them in your head as well. So we might hear words like split. We might hear a word called evenly, groups, or share. These are all good ones. Evenly, groups, you might hear the word they're going to slice into pieces. So slice or separate or break. Slice and separate. You might hear the word cut or package, like putting them into packages. You might hear, let's see, did we do evenly? Yeah, we have evenly. You might actually hear the word divide or share. We already got share. So we're going to do divide. You might hear fair share, or making sure that it's fair. You might hear quotient, divisor, dividend. Those are all words we would need. So dividend, divisor, quotient. I think that's good enough. I think that is a good example. Okay, so now that we have all of these words, we're going to circle them with a pencil. These words are not the only words you would see for a division story problem. They're just some words to look for. Oh, you know one that we didn't put on here that comes up? It's pretty crazy. We dealt with this, in our last math video, actually, and the phrase times came up, and it meant divide, not actually multiply. So times as much. Sometimes if they give you a problem when they're asking you to work backwards with the phrase times as much, they mean divide. That's pretty interesting. And we're going to circle all of them in red. And then what we're going to do is we're going to make sure all of these words get connected somehow with yellow. So after you've circled all of them in red, you're going to go back through with yellow and make this really cool connection. I'll show you in just a little bit. But be thinking of these words as you're going. Recognize them in story problems because they're going to come up. And not just today, they're going to come up always. And you need to be able to tell whether it's divide or multiply. So that's why this is important. Okay, now all of mine are connected. So I'm going to take my yellow and I'm going to draw yellow connecting lines like a big web. Okay, so I'm just going to kind of make this all be connected. just make sure they all get connected in there. Okay, then off to the side, we're going to write, these are division word clues. I'm going to write that over here to the left. These are division word clues. If you see these words in a story problem, it most likely means that you are going to divide. Okay? That's how that works. Okay, now we're going to look at our workbook, page 195, and we are going to practice some of the problems on there. Okay? So, number 7 says, the problem at the right might seem unfinished. The leftover number at the bottom is called the remainder. We can write the answer like this, and they wrote it like a 4th grader would write it. 567, remainder 2. Could there be a remainder of 9 for this problem? Why or why not? Look at what the divisor is. We've actually always used, I think we've always used the other color, but we're going to use, I should have used red since the remainder down here is yellow. Well, I can change that. It's just going to look a little orange. That's okay. The divisor here is 8. So could I have a remainder of 9? Remember that rule in our journal. It says you can never have a remainder that is more than the divisor. So the answer is no. It cannot be 9. Could there be a remainder of 9 for the problem? No, comma, there could not be. And then it asks you to answer the question, why or why not? Sorry about the dog barking in the background, that's fun. Why could there not be a remainder of 9? The divisor is 8. So having 9 left over means you could have made another group. So no, there could not be. The divisor is 8, so having 9 left over means you can make another group. So on number 8, it says, what is the greatest possible remainder when dividing by 8? So it can't be 8, because then you can make another group. So what is the greatest possible remainder when dividing by 8? It would be 7. So I'm going to write, it would be 7. And then on the next part, it says, use any division method, complete each division, and give the remainder. I want the remainder as a 4th grader would write it and as a 5th grader would write it. So let's just take a look at, let's do number 17. It says 5,420 divided by 6. I want you to repeat how that division problem is read. We do not begin by saying the divisor. We begin by saying the dividend. So are you ready to say it with me? Number 17. 5,420 divided by 6. And because it's already set up in the standard algorithm, let's keep this one in the standard algorithm. Okay? So will 6 go into 5? You look at the first digit. Remember, you go 1 at a time. No, it will not. So you put an X there. Will 6 go into 54? Yes, in fact, it goes in perfectly. 6 will go into 54 9 times. So you put the 9 right next to the X, and you're working one number at a time. So now I'm going to go like this. Okay, well, what was 6 times 9? It's 54. So I write the 54 under the 54. I subtract it, and I bring down the next number. I start the process all over again. Will 6 go into 2? Will 6 go into 2? The answer is no. So when it will not go in there, you still have to go through the process. You have to put a 0 in your quotient. And you have to go through the process and say, okay, well, it wouldn't go into 2. So I put a 0 there and I bring down the next number. That's pretty rare that you're going to have a 0 in the quotient, but it does happen. Okay, so now I start over. Will 6 go into 20? The answer is yes, and it goes in 3 times. So where do I put that 3? Yeah, in the answer line, in the quotient line. I did those steps without telling you, so hopefully you'll know what's going on. Are there any more numbers to bring down? No, so pick up your yellow and circle the 2 as your remainder. Can the remainder be 2? Is it smaller than the divisor? Yes, it is. So I write it as a 4th grader up here by just writing remainder 2. I circle my answer, don't include the X. And then I write it as a 5th grader would write it. Keep the quotient the same. And change the remainder into a fraction. Remainder is on top, the divisor is on the bottom. This is one of those problems I was telling you about. You need to simplify this. Will you please write simplify? You need to simplify the 2/6. How do you simplify 2 and 6? You have to divide them by the same factor. And the biggest one that you could divide both of them by is 2. So I get 2 divided by 2 is 1. 6 divided by 2 is 3. So it's 903 and 1/3. I'm going to circle that with red, showing that that is my final answer. Pretty crazy how I went through all those steps. I wrote it like a 4th grader, 903 remainder 2. Then I wrote it as a 5th grader, 903 and 2/6. And then I wrote it as a student in Miss Fisher's class who has to do extra work and has to simplify. You're welcome. Then I wrote it as 903 and 1/3. Pretty great. Okay, should we try another one of these methods? Maybe we should try number 15. Scoot it over. Number 15. Will 9 go into 5? No. So I put an X. 9 does go into 54 6 times. And 9 times 6 is 54, so I write it under the 54 and subtract it. And then I bring down the 6. And I start the process over again. Every time you bring a number down, you start over. Will 9 go into 6? No. When I say no, it means a 0 in the quotient. And I bring down the next number. Will 9 go into 69? Yes. 7 times. And that's 63. So I subtract that from 69. And I get a remainder. Can 6 truly be the remainder? Yeah. Circle it in yellow. Write it as a 4th grader, Write it as a 5th grader. Oh no, 6/9 can be simplified. Divide each one by 3. Oh, I'm sorry. 6 divided by 3 is 2. 9 divided by 3 is 3. So Miss Fisher's class would have to write it like that. 607 2/3. Hopefully you show the steps of having 607 and 6/9, which changes into or simplifies into 2/3. Pretty great. Okay, we're going to turn the paper over and we're going to look at some real world examples. We won't be doing all of these, but turn the paper over and let's take a look at what it says. It wants us to use mental math to check for reasoning, but I actually just want us to solve these problems. So what we're going to do is take our red pencil and we're going to, or red crayon, and cross off 18 through 21. Just a big red X. And let's begin by looking at number 22. It says, Kim makes necklaces with colored beads. She used 1,620 beads for 9 necklaces. How many beads did she use for each necklace if they have the same number of beads? I think if we look in our journal, we hopefully said the word each. I'm getting nervous that we didn't. We didn't! Grab your journal. Oh yeah, we are adding it. The word each is important. It can mean multiplication sometimes, but it can also mean division. So, good thing we spot checked that. Make sure you add the word each to your journal. So now you obviously know what I'm going to make you underline, right? So she uses this many beads for 9 necklaces. They have the same number of beads, so how many did she use for each? This means division. Make sure you're making all the red marks on here. You're going to be turning this paper into me today, so hopefully you're following all the directions. Because you will owe a stamp if you don't have the right colors and all the right markings. Okay, so let's do this as a place value boxes, okay? So that those people who like doing it that way can see it represented that way. Here we go. 9 is the divisor and 1620 is the dividend. So you should set it up like that. 9 doesn't go into 1, so place an X above the 1. But 9 will go into 16 only once. But remember, in this method, we fill in the place values above. So it goes in 100 times actually. And when you do this, you have to be super careful because you have to go, well, what is 9 times 1? It's 9. And that number goes right underneath the 6 because that's where I started. And then I have 2 more zeros. So 9 times 100 obviously is 900. And I subtract those to find out what's left over, and then draw your next box and continue. How many times will 9 go into 7? It won't. How many times will 9 go into 72? 8 times, exactly. But it's not just 8 because you have to get that filled in. And what is 9 times 80? It would be a 72 with a 0. We'll look at that. If I end in 0, it means I know what my answer is because I combined the quotient lines, the partial quotients. So how many beads did she use if they each have the same number of beads? That makes sense that there's not a remainder so that you don't break the beads into pieces to put on the necklace. That would make sense. So they each have 180 beads. Okay, next. Saul delivers equally. Haha, that's a key word. Saul delivers equally, which is very similar to evenly, and that's what we put in our journal. 155 newspapers in a 7-day week. How many newspapers does he deliver in a day? So he delivers the same amount. So it's 1155 divided by 7. Let's do this method again. And why don't you work through this process until you get to the end for me? You can watch me, but I'm not going to talk about it. Are you working through it? Did you finally get to a box that is like, oh, easy, I know that? Did you prove it by going to 0? Did you get the same answer as me? So how many newspapers does he deliver in a day? Saul delivers. Make sure we got the same number. Did you get 165? That's the correct answer. Pretty awesome. I love doing division story problems. I think they're super fun. Let us do the next one, number 24, but we're going to do long division on this one. Okay? Long division means the standard algorithm. So on number 24, Val earns $1,096 a month as a cashier. She makes $8 an hour. How many hours does she work in a month? So it tells us her total, tells us how much money she makes an hour, so we have to divide that to find out how much she makes in a month. So the phrase in a month is actually the division phrase. Pretty interesting, huh? So to do this as long division, I take out the dollar signs. I use 8 as the divisor. And I put all these numbers in 1096 without commas. So instead of using a long space, we use a tall space for long division. Pretty cool, huh? Okay, 8 won't go into 1, but 8 will go into 10. So you put the 1, because it only goes in there once, you put it above the 0 for the 10. That looks really confusing with my X right there. Make sure yours looks really clear. There we go. 8 times 1 is 8. I subtract and bring down. Every time I bring down, I start the process all over again with that number. 8 goes into 29. Almost 4 times, but it's not. It's only 3 times. So you put a 3 above the 9, because that's the next place up here. And you subtract. And you bring down, and it's beautiful. 8 goes into 56 exactly 7 times. But you have to show, just like with the other one, that it ends in 0. So, how many hours does she work in a month? She works 137 hours. Seems like a lot, doesn't it? Well, most people's jobs, if they have a full-time job, they work 40 hours a week, which ends up being 160 hours a month. So she doesn't really work a full-time job, even though that seems like a lot of hours, huh? Okay, and the last one, number 25. The Martins in school bought 1,890 water bottles to distribute equally among students. There's that word. Distribute is actually a cool division word, but equally. Also, we have one of the amounts right here. To distribute equally among students over a 5-day period. How many bottles are distributed each day? There's another one, each. And distributed, this one is clearly division. So you take your total, divide it by 5, and that should tell you how much they can give out each day. Because I don't have a long skinny space, let's do the box method, okay? Let's just start the first one right here. I'm running out of lead, sorry about that. Okay, 1890, and the divisor is 5. Think about this. Are we going to have a remainder left? No, because if you're handing out water bottles each day, you're not going to hand out a piece of a water bottle. You're going to hand out the whole thing. So if I get to the end and there's a remainder, I probably did something wrong. Okay, that's logical thinking. Go ahead and solve this, the box method. If you need some help, I'm going to walk through it. If you already know how to do it, go for it. 5 doesn't go into 1, so I place an X. 5 does go into 18 3 times, but it's 300 times, not just 3. 5 times 3 is 15, but it's with 2 zeros. Once you get that leftover amount, you should draw the next box. It's going to work out. Make sure it ends in 0. So how many bottles are distributed each day? Did you get 378? $378 bottles are distributed each day. So when we solve division problems, we have multiple methods that we can do this. We can do it in the place value way, where we draw boxes, we carry over leftovers, we fill in place values with zeros, and then we add partial quotients. Or we can do the standard long division algorithm, which is to go one number at a time, to subtract and bring down, and start the loop all over again. That loop is divide, multiply, subtract, bring down. Say it with me. Whisper it. Here we go. 3, 2, 1. Divide, multiply, subtract, bring down. Let's write it up here by the X. I'm going to be checking for this. So why don't you put it in a yellow box? Again, you're turning this paper in, and I want to see all of the correct markings and that you followed all of the steps. So in this box, you're going to write divide, a big D, multiply, a big M, subtract, a big S, bring down, BD. Divide is the division symbol, multiply, subtract, bring down is the arrow. I'm going to be checking for that box. Say it with me again. Divide, multiply, subtract, bring down. Again, divide, multiply, subtract, bring down. Last time, divide, multiply, subtract, bring down. Okay, make sure that your name and number are on this side especially. Well, technically I want them on both sides. Name and number on the green, and name and number on the other side. Double check it that it's on both, and then take your paper and turn it into the math basket. Today for math, you already have done the remembering side, and so you do need to get on Think Central and complete the assignment for 5.1. Again, you need to get on Think Central and then you need to complete the homework 5.1. Thanks for hanging in there. I hope you love dividing as much as I do. Catch you next time.